All right, well, welcome to all of you. I'm the other Rick Keefer. For those of you in the Historical Society, my son, Rick, is the president, but we're here and we have all the way, we have all the way from Frewsburg and the
Martz Observatory.
That's what I was thinking. And so we're going to have a nice chat here. And I'm trying to figure out what I'm doing. The technical guy is here. I want to thank Fluvanna Church for letting us come. Want to thank the Fluvanna Historical Society for their help in this. And then also the Chautauqua County Health Department has helped out in us in that long way. So here's Tom, and here we go.
You're good at that.
Thank you very much. My name is Tom Traub. I'm from the Martz Observatory. I'm Vice President of the Marshal Martz Memorial Astronomical Association. We are the entity that runs the observatory. We are a 501c3 organization, and we promote the space sciences through STEM camps with the students, educational outreach, and many other programs and projects. So I'm glad to be here. I am a NASA partnered Eclipse Ambassador. There's over 700 of us across the United States. What we are doing is we are bringing information about the upcoming total eclipse of the sun to the general public, both on what to expect out of what a solar eclipse is, but also to give you some taste of what you're in for and also some precautions. We want this to be a once-in-a-lifetime memorable experience and something that you can talk with your family and friends for many years to come. So I guess we're going to start out here. First is we're going to talk about the two types of eclipses that we have. Okay, we have two types of eclipses. The first eclipse is a solar eclipse. That's when you can't see the sun because the earth is in the way, and they don't occur very frequently. The other type you have is what they call a lunar eclipse, and that's where you can't see the moon because the earth is in a way, and they happen much more frequently. In fact, it actually happened at 3 o'clock this morning. There was a penumbral eclipse of the moon, and I will sort of explain what happened with that and why it happens. So, why are solar eclipses so rare? Well, we travel around the sun once a year. That's both the Earth-Moon system together. Now, the moon is orbiting the Earth, and it orbits approximately once a month. In this case here, in 1 year's time, the moon will go around the Earth 13 times in a year. So, why don't we have eclipses once a month? Well, it has to do with how the Earth, the moon, orbit both each other and how we orbit the sun. First of all, one of the things is on the Earth-Sun plane of the solar system, which is called the ecliptic, where most all the planets in that line, the moon's orbit is tilted by 5 degrees. So what happens is, because of that 5 degrees, sometimes the shadow of the moon passes over the Earth. Other times, the shadow of the moon passes under the Earth. It's only where that plane of the moon crosses the Earth-Sun plane in a place where they call a node that an eclipse can occur. And that's just a very narrow portion of the orbit, and it continuously changes because of where the Earth and the moon are in their position around the sun. It's the same way for a lunar eclipse. If the moon is too high, the Earth's shadow doesn't pass onto the moon. If it's too low, then it doesn't pass onto the moon either. It has to be right in the node, When it's in the node, the shadow of the moon can pass onto the surface of the earth, or the shadow of the earth can pass onto the moon. So this, as we're seeing here, in this case here we have the moon is too high and the shadow is passing over. Here the moon's too low and it's passing underneath. Same thing over here. But when we're at the nodes, when we're all in alignment, then the shadow of the moon comes onto the earth, or the shadow of the earth goes onto the moon. And these are only very special cases. In fact, what happened is 3,000 years ago, the Chaldeans, which were before the Sumerians, actually started studying lunar eclipses, the eclipses of the moon. And what they saw is there was a periodicity or a cycle to it. They seemed to reoccur every so often. In this case, every 18 years, 11 days, and 8 hours later. And this is what's called a Saros. It's the cycle of eclipses. It's the cycle at which the alignments of the earth and the moon and the sun happen again in almost exactly the same sequence. So, as an example, my first eclipse I saw was on March the 7th, 1970, on the east coast of the United States. That was in Saros cycle number 139, because there are multiple cycles going on. So, in that case there, what was happening is, with these Saros cycles, is the next one that would occur was going to be 18 years, 11 days, and 8 hours later. So, in 1988, there was another eclipse out of that Saros. But because the Earth had rotated 8 hours, that now passed over the western Pacific Ocean, off the coast of Japan and China and the Philippines. It was mostly in the ocean. Another 18 years, 11 days, and 8 hours later again, there was another eclipse of the sun. And that one occurred in 2006. And it went across Central Africa, Eastern Europe, and the USSR. So, 18 years, 11 days, and 8 hours later, we have our eclipse on April the 8th, 2024. So, in this case here, this is my third anniversary of the first eclipse that I ever saw in Saros years. So I'm sort of celebrating seeing the same set of circumstances as the eclipse that I saw way back on March the 7th, 1970. But it has shifted a little further west and a little further north than what that original one was that I saw in 1970. And that's the way eclipse cycles work. And there's multiples going on. So in any one given year, there could be between 4 to 7 types of eclipses going on between lunar and solar. Some years, there's only one solar eclipse. Some years, there's 3. It all depends. So they're continuously going on. And that is part of what we're talking about. So the other problem with the whole thing is that the orbit of the moon, even though it's circular around the Earth, is not even. So sometimes the moon is farther away from us at apogee, other times it's close to us at perigee. Now, if it's at perigee, closest to us, and it happens to be a full moon, we have a supermoon. And that means that the moon is about 5% larger in the sky and about 15% brighter. And everybody talks about the supermoon. Oh, it was huge. It was tremendous. It was bright. You don't hear anybody talking about a mini moon when it's at its farthest away. It's like, oh, it's really dim, it's tiny, but that changes the size of the moon in the sky. Now, the Earth orbits around the sun, and sometimes we're closer to the sun, and sometimes we're farther away. We're actually closest to the sun on January the 3rd. So actually, we get a little more solar radiation on January the 3rd than we do on July the 3rd, when we're farthest away from the sun. But what that does is it changes the size of the sun in the sky to us. So in January, it's bigger and closer. In July, it's farther away and smaller. So these things all combine together. So if we don't have the moon right exactly at the node, we can have what's called a partial eclipse. That means that it's not quite centered, but some portion of the year, Earth is going to get some piece of the shadow of the moon on it, and it's going to take a chunk or a bite out of the sun. And that's what you're going to see. Now, that can be anywhere from 1% of the sun to 99.9% of the sun. But what we want is when everything's in alignment and when the moon is larger than the sun in the sky, so that we can have a total eclipse. In a total eclipse, 100% of the surface of the sun is being covered. What that does is it darkens things up enough for us in the shadow cone of the moon that we can see the sun's outer corona, or its atmosphere around there, because it's covered. The rest of the sun is so bright you can't see it. It's always there, but you just can't see it. You have to have the sun covered, the surface of the sun covered, in order to be able to see it. Now, if there happen to be filaments of gas above the surface of the sun, they can appear over the edge of the moon, and we have these things called prominences. And they are these are filaments of gas, hydrogen gas, and they glow the color of hydrogen gas, which is actually sort of a pinkish orange color, as we would see it. And they can stick out around the edges of the sun. Now, it's all dependent upon solar activity. The more solar activity, the more filaments, the more we might see prominences around the outside edge of the sun. In fact, right now, the sun's very active. We're almost at solar maximum. So we're going to see more of these. So there's a very good chance you will see some prominences around there. Just at the last minute before totality, you can see what's called the chromosphere of the sun. That's a layer of glowing gas right at the surface of the sun, and it also has that reddish color. You can sort of see it along pieces in here. Now, if the moon is too far away from us, so it can't totally cover the sun, but we have the same set of circumstances of the alignment, then you get what's called an annular eclipse. So here's the sun, and it's not covered, but here's the moon centered on it. To see this, you won't be able to see any of this, because this much light around here is going to be totally so bright, it's going to cover it all. There will be a big difference. Now, the other thing we talk about is what's called a hybrid. And a hybrid is a combination between these two, where the sun and the moon are exactly the same size, but because the moon's edge is irregular, because you have mountains and valleys, some little pieces of the sun can peek out through those valleys. And you have a thing called Bailey's beads, these little peaks of sunlight. But the majority of the sun is covered, and that makes it dark enough that besides having these little pinpoints of light all around there, you're going to also be able to see the corona and see any of the prominences. So how frequently does this really happen? Okay, on average, every 19 months or 18 months, there happens to be a total solar eclipse somewhere on the Earth. But in most cases, you're going to have to travel to it because it's not usually very close. Sometimes they're over the middle of the ocean. Sometimes they're up in the Arctic. Sometimes they're in the Antarctic. They could be in Africa. They could be in Asia. Could be in South America. So you're going to have to go for them. In fact, if you took any one particular spot on the Earth and said, well, how often can I see a total eclipse of the sun there? On average, once every 350 to 400 years. So it is a once in a lifetime event.
Okay.
So the reason why is, again, the eclipse only covers just a tiny portion of the Earth. Even though the moon is 2,128 miles in diameter, that shadow cone of the moon coming onto the surface of the Earth can only get to about 200 miles wide. So somewhere between 10 to 200 miles wide is what you're going to expect out of the shadow cone. And that little thin shadow cone going across the Earth is moving very rapidly. It's moving approximately 2,000 miles an hour. So that little piece is only over you for a very short period of time. And that's what makes them rare. So what do we have here? What we have over here is we have what's going to happen on April the 8th. So we have this little black dot you see going across there is the shadow cone of the moon. And this is the path that it takes across the surface of the Earth, starting over in the South Pacific and moving along until it hits Mexico and the United States, over Canada, and ends out in the North Atlantic. Now there's a larger circle around there. The larger circle is where a partial eclipse of the sun is going to occur. So anywhere within this circle, the sun will cover a portion, or the moon will cover a portion of the sun as seen from the surface of the Earth, anywhere within that circle. Anywhere from 1% to 99.9%. What you want to do is you want to be in this little yellow band. That's where it's 100% coverage of the sun. So I looked to see what were the circumstances for here in this area. So I went from 1,500 BC to 3,000 AD, and there were 1,761 eclipses that occurred. But out of those, only 34 were either a total, an annular, or a hybrid. In fact, it was 16 total eclipses, 17 annular eclipses, and 1 hybrid. So when did we have the last total eclipse of the sun here in our area? June the 19th, or excuse me, it's June the 16th, 1806. So, quite a while ago. Now, if you miss the one in 2 weeks and several hours, you'll have to wait until October the 26th in the year 2144. Now, some people say, well, I remember seeing an eclipse a couple of years ago. What they probably saw was the annular eclipse of the sun that occurred over our area. And the last time that happened was on May the 10th, 1994. Many people might have observed it, but they were using a thing called pinhole projection just to project an image of the sun that they could look at. And we'll talk about that in a little bit. If you don't see this next one is on July the 23rd, 2093. And in all that recorded 4,500 years, there's been 1 hybrid eclipse that has gone over this area. And that was on, and this is I've got a typographical error in here. It was on January the 19th, 1768. The path was only 10 miles wide, and it went right over the observatory, and it lasted for 10 seconds. Maximum. So they are rare events. So we have to appreciate them when they happen. So what we have here is the path of totality. In other words, this is the path of the shadow cone of the moon over our area. So it's, as you can see, it's this band that goes across here just like this. It's 110 miles wide. And you want to try to be in the center of it to be in it the longest. Well, as we can see from here, here's Cleveland, Ohio. Here's Erie, Pennsylvania. Here's Buffalo, New York. Here's Rochester. Here's Syracuse. And then we go over this way. Up here, we have Montreal and onwards. Toronto's going to miss out. They're only going to get like 98% coverage. Detroit's going to miss out. Pittsburgh's going to miss out. Albany will miss out. They're only going to see a partial eclipse. This is where you want to be. Now, if you're along the edges of the eclipse here, whether it's the southern limit or the northern limit, you're only looking at between 10 to 40 seconds of totality. But at the center, when it's coming into this area, you're looking at about 3 minutes and 45 seconds. In fact, let's look at it a little close-up of the area. So, again, these are the lines. So, the center line goes to the middle of Lake Erie. Well, they don't want people out in the middle of Lake Erie trying to look at the eclipse, but somebody's going to. So, I know that the Coast Guard has brought in helicopters and extra boats into the area. So, in case something happens, they can have a faster response, other than having to come all the way from Detroit, Michigan or further. So Buffalo is going to get 3 minutes and 45 seconds. Okay, Niagara Falls is going to get 3 minutes and 11 seconds. Rochester, 3 minutes and 39 seconds. Syracuse, 1 minute and 24 seconds. And onward as it goes. It's going to go over Lake Champlain.
What do we get?
It depends on where you're at, and I will discuss that. We actually
I'm moving them too quick.
have a paper over here that on there has all the cities in about a 90-mile radius and how long totality will last in each one of those towns. So you can look on there for Fluvanna, and you can find it. You can find Lakewood, Brockton, all the different cities in the area.
So like Lakewood, that close together is going to be different.
Yes.
timing.
And I will show you why. Okay, this is when the eclipse is almost maximum over our area. So this is what the footprint of the shadow covers on our area. So this is based at 3:19 and like 21 seconds in the afternoon. So it's 110 miles wide and covers from Warren, Pennsylvania, all the way up past Hamilton, New York, or Canada, from Pontiac, Ohio, all the way past Medina, New York. And it's moving past us at 2,296 miles an hour. So that's why this doesn't last very long, because it's really buzzing along here. So depending upon where your location is here, depends on which section of the cone comes over you. See, when you get to closer to the edge, a smaller section of the shadow comes over you, so it lasts a shorter period of time. That's why everybody wants to go on the center line here, because it covers the largest section of that shadow cone. And that's going to give you the longest period of time in totality. So wherever you are here is all going to change what you're going to see and how long it's going to be. But normally, as most people around here are saying, okay, well, the closer I get towards the lake, the longer it's going to be. But so everybody else is thinking the same thing, just to let you know. Everybody has the same idea for this.
So they can't all be wrong.
Yeah. What are you going to see?
It's going to be a lot of people.
So what are you going to see? The picture that's over here on your left was taken mid-totality on August the 21st, 2017. That's when I was on the center line in Beatrice, Nebraska. What you see here, up here, is the shadow of the moon overhead. And in that shadow, it will be dark enough that the brighter stars and planets in the sky will be visible. Around you for 360 degrees is going to be sunset. That's where you're looking outside the shadow of the moon. Now you will see that shadow coming over you. You will see it darkening come, and then very rapidly it's like it's over. And when that happens, the air temperature is going to cool down by about 10 degrees. Because of that rapid cooling of the air, you're going to get a breeze that's going to start up also. Now, birds are going to go roost because they think it's nighttime, twilight. You're going to have roosters crowing because they don't know whether it's dusk or dawn. You're going to have peepers peeping. You're going to have crickets chirping. Animals are going to be confused. They're not going to know whether it's dusk or dawn, and they may act erratically. So this is something for you to look for. You can also look at the changes in the sky and the clouds, because as the eclipse continues on, it's going to change the local conditions. In the middle of where the sun should be, you're going to see this. This was the picture I took during totality. So the black spot is the moon, and it's the unsunlit portion of the moon that's looking at us. It's a full moon on the back side of the moon, but for us, it's new moon, and the only light that it's getting right now is the light reflected off of the surface of the earth, off the clouds in the oceans, going back onto the moon. But it's not bright enough during this event for you to see it. So it's going to look like a black hole in the sky. And around it is going to be the corona, the sun's atmosphere, outer atmosphere. And its shape is going to be dependent on the solar activity. The more solar activity, the more streamers will be coming off of it, the more you'll see polar vortexes and such. And this will go out for several sun diameters on either side. And there may be protrusions around the edge. These are those high filament clouds, those prominences that will be visible. From space, it looks like this. If you were looking backwards, there's this black area right here, and in the center of that is the shadow cone of the moon that's racing across the earth. Now, as an example of the difference between an annular eclipse and a total eclipse, this is a sequence that I took from Cannarville, Utah on May the 20th, 2012. It started with the partial phase all the way through, and then we finally had totality. And then we started coming back out of totality near the end of it. The reason why this is the last picture, and you see this here, this is a tree on the mountain to the west that the sun was setting behind at the time. Now, this is mid-totality. This was taken here. Just as if this was a total eclipse and this one here was taken there. That's the difference. It almost just looks like a sunny day. Unless you had solar glasses on, you probably would not know that the solar eclipse was going on. And the people here came from all over the place. There were people from Alaska that were joining us there. There were people there from Seattle, and they were wearing aluminum foil hats on their head. And they were having the most grand time. How much of the eclipse they actually will remember is questionable. But they really were into it. They wanted to see what an eclipse was. And so they came all the way from Seattle down to Cannarville, Utah, which is right near Zion National Park, and decided to see it. Now, there were people there from California, also from Wisconsin. They come in from everywhere to see these events, and that was what's going to happen into our area.
Question.
Yes.
If that's a picture during the eclipse itself,
Yes.
how dark is it going to actually be?
It will be like at least about a half hour to 45 minutes after sunset. It will be just like twilight, very deep twilight.
Okay.
So now we get into the important things. First of all, sunglasses. No sunglasses. Sunglasses do not protect your eyes. If you try to stare at the sun with sunglasses, you are going to irreparably damage your eyes, because those lenses in your eyes are going to focus the sunlight and burn your retina, and that does not repair itself. So you don't want this to be a memorable experience with blurs or spots in your eyes for the rest of your life. No sunglasses. Anytime the sun is uncovered all the way up, and I mean all the way up until 100% coverage of the sun, you need to use special protection. Now, what we ask you to do is you need to have a pair of safe, certified solar glasses, such as these. Now, these are to the ISO recommended number 12312-2. That means that these solar glasses will protect your eyes from infrared, ultraviolet, and all the rest of the wavelengths in between, and allow you to safely observe the sun. It's going to drop the brightness of the sun by about 10,000 times. And anytime that the sun's out, you can use these to look at the sun. But please put them on. And because if you have glasses, the other thing that's important is you put them on in front of your glasses, not behind them. That's important, because if you have a stronger prescription in your glasses, it's going to concentrate that light more on these filters, and more light's going to go through them than should. Whereas if you have them behind, then the light coming through and concentrated by your glasses is safe. And that's what we want people to have, is a very safe experience. So any day or the day of the eclipse up until the time of totality, which is when the sun is covered 100%, you need to use your solar glasses. Now, what happens is, as you get very, very close to totality, the sky brightness is going to go, it's going to get darker out. And the sun's going to get dimmer. It's because more of it's covered. We have a normal aversion to look at a bright sun. We look away from bright lights. That's innate in our physiology. The problem is, when you get to that darker point, it's not as strong, and you might want to look at it a little bit longer. And the problem is, you're looking at it a little bit longer, but the damage is still occurring. That's why you need to have these on until then. Now, once totality hits, then you take them off and you look at this fantastic, awesome event that's going on all around you. Look at the prominences, look at the sun, look at the planets in the sky. Look around you, what's going on, the effects in the sky. That's what you want to do. Then you want to try to remember that during this awesome event that's going by extremely rapidly for you, to get your glasses back on before totality ends, so that we have them on when the first vestiges of sunlight come back out as the moon uncovers the sun. Now, if you get so engrossed that you forget to get them on before the first flash of sunlight happens, as soon as that happens, you need to immediately look away, because one of the things is, as you're in that darkness, your eyes are going to open up wider. And that just allows more sunlight in when that first sunlight comes back. So it's actually more dangerous at the backside of the eclipse than at the beginning of the eclipse. That's the safety you want to do. Now,
Another question.
yes.
If we already have glasses, is there the number
You should
on there?
find the certification on the inside of the glasses that said ISO 12312-2.
Got it.
That is the certification. That is the international standard for safe solar observing glasses for the filters. Now you also have an eclipse filter like this, and it does the same thing. This film is the same film that's used in glasses. It's just a handheld one like this, so you can do this. One of the things that people have a problem with is they're going to want to take pictures with their cell phone.
Yeah.
Okay, you must treat your cell phone like your eyes. If you're going to try to take a picture of the partial eclipse, what you need to do is you need to have a filter over the camera section of your cell phone. If you don't, you will burn out the imager in your cell phone and you won't be taking pictures anymore.
Jeez,
It's that
there's gonna be a sale.
But what you need to do is, you have to remember, you don't put this up and look like this and adjust your cell phone here with your eyes unprotected. So you'll burn your eye out here, but you'll protect your cell phone. And you can't do this.
Wow.
Have these on and do this, because these drop the light by 10,000%. Guess what? You're not going to be able to see the screen on your cell phone. So what we do is you hold the cell phone down below you. Put this on here so you can see the screen, not looking up. Take your pictures, and I've seen some great pictures I was on the annular eclipse in Albuquerque on October the 14th last year. And I saw some beautiful pictures that people took with their cell phones of the annular eclipse, doing it this way. Now, when totality hits, your cell phone is like your eyes. You can take it out of the way and you can take a picture. Now, if you have a camera and you're looking to take pictures of the eclipse, first of all, you better have a full solar filter for your camera. If not, let's say you have a nice Nikon camera, you're going to destroy the imager in your $4,000 camera. You need a full, complete coverage of the front of the lens on the camera. Treat it like your eyes. When totality is, you can do it off. Now I'm going to tell you, if you've never ever seen a total eclipse of the sun, you do not want to waste your time trying to take pictures. If you're sitting down here and you're trying all these different ones and snapping this, you're missing what's going on around you. And it's going to be a long time until you can see that again. There are going to be people that will be taking pictures of the eclipse. There will be tens of thousands of these people. Let them do it. Because most of them have seen more than one. They know what to do. They know how to do it. And they're doing the same thing I'm going to do. This is going to be my 9th eclipse. So I'm going to be the one taking the pictures at the observatory. I'm doing that because I want everybody else that's going to be at the observatory, the membership, to observe the eclipse. And then those pictures will be available to them. So it's a win-win situation that way. Also, no binoculars, no telescopes. The reason why is now you're concentrating even more light into your eyes if you try to do that. If you happen to be looking with a pair of binoculars and that sun gets uncovered, bang, instantly eye damage. I mean, because you just increased by a tremendous amount the amount of light going into your eyes. Same way with a telescope. Anyways, telescope, binoculars, you're looking at a smaller portion of the sky. You're not going to see everything that's going on. It's not worth it. Use your eyes. Just visually observe. Leave it at that. That's the way to watch the eclipse. Now, there is another safe way we can do this. And this is one that's been used for hundreds of years. It's called pinhole projection. what we do is we take a piece of cardboard and we put a hole in it. Now, we suggest the hole be smaller than 1/4 inch in diameter. A nice paper punch is a good size diameter hole. And what we do is we hold it up into the path. And what happens is it projects onto a surface. So the sun is behind us and we're looking at the surface. So we're not looking at the sun. But this acts like a camera obscura and creates a miniature image of what's going on with the sun. And it doesn't matter whether you have a triangle, a circle, or a square. At distance, they're going to project an image of the sun. Now, anything else that you see down around you, like say you have chairs or items that have pinholes in it, they're going to project hundreds of these little miniature images of the sun and the moon as it's in partial eclipse, because they're all going to create pinhole projections. So look around you, look under the trees, look at the shadows. You're going to see all these miniature changing sizes and shapes of the eclipse as crescents. It's really, really neat. So, weather. This is always a good one. So, well, it's going to be clear on eclipse day. Well, this is what I can tell you. This picture you have here was taken April the 8th, 2023, 1 year ago, in the afternoon. We are clear. It was perfectly clear sky. There was no clouds. In fact, out of the last 10 years, 6 of those years, there was less than 40% clouds in the sky. So 60% of the sky was clear during the day of the eclipse, especially in the afternoon when we're looking at the eclipse. Go to 25 years. 25 years, the average is that on any given day, there would be 61% of the sky with clouds. That means 40% of the sky is going to be clear. So overall, we have a very good chance, in fact, one of the best chances in the United States to see the eclipse on the day of the eclipse. You have to go all the way down into Texas before you're going to have a better chance of having clear skies. Well, everybody else knows this also. And so everybody's going to be coming in here. And part of the reason why is Lake Erie, that wonderful snowmaking machine that we have in the fall, acts as a stabilizer to the air that comes over it in the spring and keeps clouds from forming. So on the lee of the lake, there's usually very little clouds. Or if they are, just a small amount of clouds. You have to go far eastward away from the lake before clouds start to form. So that's our bonus. In fact, I looked at 81 years worth of records from Erie, Fredonia, Dunkirk, Buffalo, Jamestown, and Bradford, Pennsylvania. And the average is about 56% of the time it's going to be clear. Now, in 25 years, we only had 2 overcast days. Totally overcast. Now, if it should be overcast, you're still going to see a lot of the effects of the eclipse. It's still going to get dark. You will still see a lot of these things happening. You just may not see the sun and the moon that well. The other thing that happens is the eclipse itself can change weather conditions. In all the years that I've been going to eclipses, I've seen it all. I have been on the Kona coast of Hawaii, which is the northwest side of the Big Island, for a over 6-minute eclipse back on July the 11th, 1991. The way it works is the weather comes over the Big Island of Hawaii on the east coast side, dumps all the rain on the east side of the island. It comes up over Mauna Kea and Mauna Loa, and as it's dropping down, you have adiabatic heating, and the clouds dissipate. So on the Kona coast, it's almost like a desert. you're talking about 15, 20 inches of rain a year versus 186 on the other side of the island. So we went to observe on the Kona coast. Gorgeous morning, just absolutely beautiful. Sunrise coming over Mauna Kea and Mauna Loa, beautiful. Great. About an hour before before totality, yeah, a little puffy cloud here, a little puffy cloud there. As the solar heating went down because you were covering the sun, the dew point rose because the temperature went down. More clouds formed. We actually had to look through a very thin, low layer of clouds at totality. And as soon as the sun uncovered after the total eclipse, the clouds dissipated away, and it was a fantastically gorgeous, clear day. Now, on the other side of the island, it was reversed. They went from having cloudy overcast, the skies cleared, they had a beautiful view of the eclipse, and then it clouded back over again. Just the opposite set of effects. Beatrice, Nebraska, that picture I showed you over there. One of the better places they said you could watch the eclipse and have a good chance of seeing it. So, that's where we went. Day of the eclipse. Really nice, beautiful out. Just one or two really scattered clouds. As time went on, it got cloudier and cloudier until it was pretty cloudy. Then we got near the eclipse time, within a half hour of the eclipse. The temperature went down, the clouds dissipated out, and we had holes in the sky, and we saw the whole total eclipse. And then afterwards, the clouds formed back up again, and we didn't see much of the sun the rest of the day. So, the eclipse itself can create local conditions. So, the thing is, I just tell everybody, flip a coin. And that's your chances. But along the whole eclipse path, we've got if you look at the records and go by the averages, we're one of the best that there is in the whole path. Unless you want to go way down into Mexico. But there's going to be a lot of people there too. Got to go down to Mazatlan in Mexico if you can want to see the eclipse path the shadow come on shore in Mexico.
Can we expect Lake Erie to give us some kind of the same effect?
It always does. It's always doing that. So our hope is that it will be the stabilizer and we're going to have really good skies. So what do we have here? This yellow band is the eclipse path across the United States. Within there live 31,625,000 people. It is the densest population for an eclipse that's ever occurred in the United States. Now, within these other bands here, which are each 100 miles wide, if you go out 200 miles on either side, we now add in 149.5 million people. And guess what? That's a 4-hour drive to get into the path of totality. And what are they telling on TV and everything now? Go see the eclipse. It's close by. Where's all your major population centers along the United States? Right here. Where are they at? Within that 200 miles. What are they going to do? They're coming here to get there and see the eclipse. So when it's all said and done, you have about 80% of the population of the United States living right there in that band. So yes, 2017 went across the United States like this. Actually, like across this way, much less populated. Based on what they saw there, the projections are for here. So, what are we going to see? Okay, this is not a map of rivers on the United States. These are main roads going into the eclipse and the anticipated travel routes for most of the people to see the eclipse. These yellow dots are population centers, whether it's Dallas, whether it's Indianapolis, Cleveland, Erie, Buffalo, Rochester, Montreal, all the way along the way. But all these roads are leading into the eclipse. What does that mean for us in this area? What is the impact? Well, first of all, for northwestern Pennsylvania, which is a small chunk, anywhere between 65,000 to 239,000 people are going to come into the area to be in totality on the day of the eclipse. Now, some of that will occur several days before because they booked hotels or they're camping or they made reservations for a week to stay somewhere or they're staying with relatives. There's also a large contingent that says, hey, okay, we'll just drive out to it. We'll see it and then we'll leave. Okay, fine. What about New York State? New York State, 239,000 to 515,000, over 500,000 people coming into the area to see the eclipse. Now, these people will be coming in again. Now, if they're on their way trying to get into the center line as close as they can to see the most of it, as it gets closer to time, they're going to say, well, we can't get to where we want to be because of the traffic. We're just going to pull over on the side of the road and we're going to get out of our cars and we're going to watch. And that will happen. And they will start clogging the sides of the roads. They'll just get out and start watching it. And so the roads are going to narrow down. So it's going to create traffic issues also. So as part of the process, what's going to happen is the emergency services and that are stationing themselves out, whether it's, in fact, they've been they have plans made for almost the last 2 years on how to direct traffic, how to have both emergency services, whether it's for fire or for ambulance and that, located in different areas strategically, bring in like extra helicopters in that. So in case there's an emergency, they can get people there even with the traffic being extremely dense and heavy. Now, the biggest thing is what happens after the eclipse. That's when it gets really bad. Because everybody's going to say, oh, we just got past totality. Oh, okay, let's go home. We don't care about the ending piece of the eclipse. Everybody's got the same idea. They all get onto the road. As an example of what happened, my grandson lives in Longmont, Colorado. He went up to the eclipse in 2017. 2-hour drive max. It took him 12 hours to get home. Corey Swanson, who is our president, him and his family decided, they live in Kennedy, he was going to go down to Kentucky to see the eclipse. So they got up and they drove 12 hours down to Kentucky. They got onto a farmer's lot. They paid him $35 to park on his lot, and he took them up to the top where they could view the eclipse. So they watched the whole eclipse. Got done, they got into their car, they started down the road, they got to a road basically like 430 out here, or Route 62, or any 219, any of those roads, and they stopped. It was car-to-car traffic because everybody was doing the same thing. It took them 12 hours to get out of Kentucky. That's what we're going to see around here. That kind of traffic. So what also happened, and we'll go into that for a second here. So things to know in preparation. First of all, watch the weather. Be prepared. The eclipse can change sky conditions. Everybody else is going to do the same thing. So like if there's a group over here and they see that it's going to be nicer this way, they'll try to travel to it. Or a group here, it's nicer there, they'll try to travel over that way. Now, on E-Day, Eclipse Day, that's going to be really hard to do, but people will try that. So, also, if you're going to be sitting outside to watch it, or so, just be prepared. It's going to cool down during the eclipse, and there's going to be a breeze up. So, wear appropriate clothing. Be comfortable. So traffic is, and if you're gonna go anywhere, especially if you have an eclipse party planned or some other event, give yourself a little extra time to get there. It's better you get there early than miss the show, as they say. So, and tell that to anybody else that may be coming to see you. We're sort of the same way. Now, traffic is going to be bad to begin with and worse after. During the last eclipse, and I can vouch for this, and Corey can vouch for this, and that gas stations ran out of gas. Restaurants ran out of food. Corey and his family stopped into a Subway to get something to eat. That sandwich. They could make him one sandwich at the Subway. And he had one choice. They said, well, you can use our restroom, but there's no toilet paper, there's no soap. You know, it is what it is. Because everybody else is doing the same thing. Okay, also, restrooms were full and closed. So preparation is essential. If you need to go out and get something, like gas, go a day or so beforehand. Top off your tank then. You don't have to worry about it. If you need food for a party or something like that, or observing, go out a day or two beforehand and get it. So you don't have to be out on the road the day of the eclipse. Now, it will be busy. You going back ways, you might be all right, but you know, if you don't have to go anywhere, don't. So right now, hotels, motels, campgrounds, bed and breakfasts are already booked, and if there are any left and available, the prices are going to be astronomical. Currently, if you want to find a campsite in near Erie, Pennsylvania, it is $600 a day to stay in the campsite, if you can find one. If you're staying in a hotel near the center line, whether you're in Buffalo, whether you're in Erie, Fredonia, Dunkirk, Connecticut, the average going price right now is $1,200 a night. If you can find one. So, bed and breakfasts, as I know, are full. And what happens is, once they fill in the main areas, they start moving outwards. I know in Warren, Pennsylvania, which is right on the edge of the limit, all the hotels are now full. And in Warren, if you're on the southeastern portion of Warren, you're outside of totality. You actually have to go a little ways into town before you're back in the path of totality. In the center of Warren, they're going to get, where the new roundabout's at, they're going to get 50 seconds of totality. And it just gets more and more as we go onward. So also, and most people don't know this, cell phone service will most likely be erratic at best, because all these people coming into the area are going to be on their cell phones. They're either going to be talking, they're going to be watching things. All these different things are going to be going on. Or the biggest user of cell phone towers is they're going to have Waze in here or some other assistant for traveling to find a road to get to where they want to go. And that data crunch is going to bring down the cell towers. They will be overloaded. So you will lose cell phone service. Now, I know in Chautauqua County, Warren County, Pennsylvania, and Erie County, Pennsylvania, I know they're bringing in extra cell phone towers into the area to help with that traffic, with that cell phone traffic, because they know that it's going to be bad. It happened in 2017, and they weren't ready for it. So now they're preparing for a worst case scenario. As Noel Gutman likes to say, who's head of emergency services here in Chautauqua County, he goes, we would rather be over-prepared and underwhelmed than to be underprepared and overwhelmed. And that is all emergency services in the area have been talking with each other for a long time now, figuring out traffic routes, where to position everything to make it safe. And that's really important. So the other thing is the schools. It was a big worry because guess what? 3:18 in the afternoon is like around the time of totality. Same time as the kids are getting out of school. You wouldn't want to see the kids in a school bus sitting in a bus in traffic stuck for hours. Or stuck at the school, not even able to get home that way. So the wisdom of the school districts are they finally closed the schools. So that's an emergency day, or it's an extension onto the Easter vacation because it is Monday, April the 8th, which they would have been coming back for their first day off of Easter vacation. So they will be home. They will be with their parents, people that can, first of all, supervise them using their eclipse glasses safely, but also enjoying the event with them as a family event. And that's important. And it's scientifically good for them. So, what we do is we're saying, if at all possible, stay at home. Now, the thing is, the eclipse is going to start. In other words, the first coverage of the moon in this area is going to start at 2:03 in the afternoon. And it will progress all the way until totality will occur right around 3:18. Now, depending upon where you are in that shadow, it may be a minute or so earlier or a little bit later. Again, it's how that shadow passes over the cross dust. It will end about 4:31 in the afternoon. So what we say is, anytime like today onward, look and see where the sun's at 3:30 in the afternoon. If you can see that and you can put your hands up like this to where the sun's at, again, don't look at the sun, but make a generalization and say, okay, here's the beginning of the eclipse. So as we're looking at the sun, here's the beginning of the eclipse. Here's the end of the eclipse, and totality is in the middle. That gives you the width that the sun is going to travel in the sky during the whole duration of the eclipse. And we say, that's your place to be. Get yourself hunkered down and ready for a once-in-a-lifetime event. So with that, I'm going to turn it over to any questions that anybody may have now. Yes?
What if they have small children, and regards to their glasses? Should you have them, keep them on even during the totality so you don't?
Well, if you do that, then they're not going to see it.
Okay.
Could you
can't see
repeat the
anything
question so they can hear that?
Okay, the question is if you have small children, do you want them to keep the solar glasses on during the whole event? And the answer is no, because yes, we want their eyes protected, but do you want them not to see their once-in-a-lifetime chance to see this awesome spectacle of nature? But you as parents there can tell them when to take them off and when to put them back on again so that they can see that.
I didn't realize that without it, if you had the glasses on, you wouldn't see anything then.
Yes, I mean, the sun will get, as it's covered here like this, when it's at this dark brightness level, you won't see anything through the glasses. It'll totally be gone.
It's a special type of lens in there, right, Tom?
Well, yeah, the filter that's in here is going to dim the sun by 10,000 times. So as soon as the surface of the sun is covered, you won't see anything in here. It'll be just blank.
Thank you.
Yeah.
And these are made to fit adults or children, so.
Other questions?
What about pets?
Okay, we did have a question, and this has come up several times, especially if people have pets. Okay, first of all, if you're concerned about your cat or your dog, and will they get harmed or damaged by the eclipse? First of all, animals are going to be pretty much oblivious to what's going on. They don't, it's just another time of day for them. Now, they may be into a routine and they see that something's out of kilter, and that may change their, idea of what the time schedule is, and so they act a little different. If you're worried about it, make sure they're indoors. Put them in a room where they can't see the sun, or close the shades and have them in that room. Leave them inside. It's not going to mean a thing to them. They aren't going to know what's going on. They're not going to understand any of it. And if you want to protect them that way, that's the way you protect them. Just keep them out of the sun during that time. Do you take them and protect them the whole time you're out walking them, the dog, during the day in the sunshine? No. It's the same thing with any of those animals. But if you're that concerned about it and you really want to make sure of it, then that's what you do. You put them in where they're protected.
Tom, I don't think you hit on it as much, but there are going to be some studies regarding animals because,
Yes.
like keepers coming out at night.
So the other
Everything.
thing that's going on is NASA has a program for citizen scientists, whether it's students, whether it's the general public. And you can find that on the Globe program. It's a NASA one. One of the things the study they're looking for is to study the types of clouds and how they change, or the brightness of color of the sky during the eclipse. And you write that down and you mark it down. Another thing is, you may make notations on whether you see animal behavior, how much kinds of animal behavior. I know the zoos, Buffalo Zoo, Erie Zoo, and that, they're stationing people all through the zoos to see what happens with the animals in the zoo during totality, to see how they actually change their behavior. You have also, they're looking for sound bites. Take a recording of all the sounds around you that happen during the eclipse, whether it's peepers or birds chirping and that. This is all valuable scientific data. If you have a simple thermometer, take temperature readings. All of this is very relative, and NASA's looking for these observations because you'll have people spread all the way across all the portions of the path of totality, besides outside of totality. And that helps them to better study how a total eclipse modifies nature. And there are multiple different studies going on. So that's something else that you as the average citizen can also do. Yes?
Thinking about the animals, how some of the animals get a little weird if there's a full moon or something. Do we expect any kind of a weird behavior because of this slack in here?
Well, it's
I mean, 'cause you have papers going and
it's a very rapid change. And so I think some of those ones would normally happen over a larger extended period of time. And that's part of what the study's all about, is to see whether that's going to happen or not. So it will be interesting. So start taking your notes. But don't forget to put most of your time into seeing that wonderful, awesome event that's going on in the sky. Any other questions? Yes?
I have read that it can affect humans emotionally. Have you experienced any of that?
Oh, you are going to see every emotion in the book from people around you. In the case of like Beatrice, Nebraska, where I was at, there was about, the town's about 9,000 population. And there were about 40,000 people in town. So around us, there were hoots and hollers. People were crying. There was every emotion in the book from people. And that's what it elicits out of people. And the experience for each person's different. Some, it's a very religious experience. In fact, for many indigenous Americans, they hold the sun and moon in very high respect. And they will refuse to actually watch the event. They consider that a sacred event that's happening in the sky. And they will refuse to watch it. Now, I have talked to the local Seneca Indians here and asked them what their take was on it. Again, They hold the sun and the moon and that in very high reverence in that, but they have no qualms with watching the event themselves. They see it as a spectacular occurrence in nature. So it's going to be different experiences for everybody. Any other questions?
There is you can get a closer, I know he had it up here, but this really gives quite a closer view and of the path. And also we do, obviously, if you live outside of Jamestown, as he said, Silver Creek or different out in Jamestown will be just under 3 minutes, 200 or 240. or
Jamestown itself in the city is 2 minutes, 54 seconds. If you're over in Lakewood, it's 3 minutes and
But
5
if you want
seconds.
to
Just that.
get exact,
distance.
you can get these
Yep.
to look at it if you're outside Jamestown.
One thing people have asked, well, what about photography? As far as photography, if you really are serious about doing it and going through with it, one of the best sites that I can tell you about is called MrEclipse.com. It's by Fred Hispanic, who used to run the NASA Prediction Center for eclipses. He's been on, dozens of different eclipses, and he does photography for them also. He has an excellent site on there on how to photograph the eclipse, should you really want to pursue that. So I want to make that available to people also. But again, you need to have precautions. Other than that, I do thank you for having us here. I hope that this is a memorable day for you, up and coming in 2 weeks and a couple of hours. And, enjoy in nature's one-in-a-lifetime spectacle. So
Thank you very much.
if you have any other questions afterwards, I'll be more than happy to answer them until we leave. Thank you again.
Okay, if also the county health department has a lot of the same stuff. If you'd like to look at that, chqgov.com. And the Fluvanna history website, fluvannahistory.com, also has a lot of links to a lot of those events that are going on and a lot of the things that information here that's already been covered and probably a little bit more. There are glasses available. I think they brought them from the observatory for it's kind of a fundraiser for them.
Yes, it's
Right.
a $10 donation.
So
Yeah.
we're a nonprofit, all run by volunteers. The only community public observatory probably in New York State. So, right, Tom?
One of the very few.
But
And for those of you on our website, we advertised if you wanted to sign up that glasses were included. Just let me know because we have those because you signed up. So again, thank you. I think there's some coffee available, and thank Fluvanna Church, Historical Society, and the County Health Department.
Thank you. Nice job.
Yep.